Welcome to the presentation on Virtual Local Area Networks, also known as VLANs. In this session, we will explore network segmentation and VLAN configuration, providing you with a foundational understanding of this essential networking concept. So, what exactly are VLANs? VLAN stands for Virtual Local Area Network. These are logical segmentations of a physical network. VLANs isolate broadcast domains. They improve both security and network performance. VLANs also simplify network management. Now let's delve into the benefits of using VLANs. One key advantage is enhanced security. VLANs allow you to isolate sensitive departments and restrict traffic between different network segments, effectively preventing unauthorized access. Improved performance is another significant benefit. By limiting broadcast to specific VLANs rather than the entire network, you reduce broadcast traffic and network congestion. VLANs also simplify network management. You can group users by department or function, regardless of their physical location, making network administration more efficient. Cost reduction is another advantage. VLANs eliminate the need for separate physical networks for different departments, thus reducing hardware costs and cabling. VLANs provide flexible configuration. Reconfiguring network segments is easy without the need to physically move devices or change cabling. Also, VLANs offer better traffic control. You can implement quality of service policies more effectively by prioritizing traffic for specific VLANs based on your business requirements. Now, let us understand VLAN tagging, based on the IEEE 802.1q standard. VLAN tagging involves adding a tag to each Ethernet frame header. The IEEE 802.1q is the networking standard that supports VLANs on Ethernet networks. The tag identifies which VLAN the frame belongs to. This enables frames to traverse multiple switches. The 802.1q standard supports up to 4,094 VLANs, with VLAN IDs ranging from 1 to 4,094. The VLAN ID is 12 bits long, spanning 0 to 4,095, with usable IDs being 1 through 4,094. Priority is indicated by 3 bits and determines quality of service priority levels. The canonical format indicator, or DEI, is a 1-bit field. Let's explore VLAN trunking. VLAN trunking allows multiple VLANs to share the same physical link between switches, or between a switch and a router. Trunking carries traffic from multiple VLANs over a single link. It uses 802.1q tagging to identify VLAN membership. Trunking optimizes bandwidth utilization. Trunking enables VLAN communication across the network. It is important to differentiate between trunk ports and access ports. Access ports connect to end devices and support a single VLAN, while trunk ports connect to other switches and support multiple VLANs. Now let's examine how to configure VLANs. First, you need to enter Global Configuration mode. To do this, type Enable, then Configure Terminal. To create a new VLAN, use the command VLAN, followed by the VLAN ID, for example, VLAN 10. Then, name the VLAN using the command name, followed by the desired name, for example, Name Marketing. Then exit. To create additional VLANs, repeat the process with different VLAN IDs and names. For instance, you can create VLAN 20 and name it Engineering. To assign ports to VLANs, enter the interface configuration mode for the desired port. For example, type interface Gigabyte Ethernet 0/1. Then, set the switch port mode to access, using the command switch port mode access. Then, assign the port to a VLAN using the command switch port access VLAN, followed by the VLAN ID, for example, switch port access VLAN 10. To configure a trunk port, enter the interface configuration mode for the desired port. For example, type interface Gigabyte Ethernet 0/24. Then, set the switch port mode to trunk using the command switch port mode trunk. Then, specify the allowed VLANs on the trunk using the command switch port trunk allowed VLAN, followed by a comma-separated list of VLAN IDs. For example, switch port trunk allowed VLAN 10, 20, 30. To verify the VLAN configuration, use the command show VLAN brief. The output will display a table showing the VLAN ID, name, status, and assigned ports for each VLAN. In this example, VLAN 1, the default VLAN, is active on ports Gigabit Ethernet 0/2 through 23. VLAN 10, named Marketing, is active on Gigabit Ethernet 0/1. VLAN 20, named Engineering, and VLAN 30, named Finance, are also active. VLANs 1002 through 1005 are FDDI and token ring default VLANs and are in an active, but unsupported state. Now let's consider Inter-VLAN routing. Inter-VLAN routing enables communication between different VLANs in a network, as devices in different VLANs cannot communicate directly with each other. There are several methods to implement Inter-VLAN routing. The first is router on a stick. It uses a single physical interface on a router connected to a trunk port on a switch, with sub-interfaces configured for each VLAN. Second is Layer 3 switch. It uses a switch with built-in routing capabilities, known as switched virtual interface, to route between VLANs without an external router. The third method is the multi-router approach. It uses multiple physical interfaces on a router, with each interface connected to a different VLAN. Now let's discuss VLAN best practices. Start with security segmentation. Create separate VLANs for different security levels. Place sensitive departments such as finance and human resources in dedicated VLANs with stricter access controls. Remember to implement access control lists between VLANs to control traffic flow based on security requirements. Practice logical organization. Group devices by function, department, or application rather than physical location. Use a consistent VLAN numbering scheme across your organization. Consider performance optimization. Separate high-bandwidth applications into dedicated VLANs to prevent network congestion. Isolate voice traffic from data traffic for better quality of service. Also, monitor broadcast traffic and adjust VLAN sizes accordingly. Next, remember documentation. Maintain detailed documentation of VLAN assignments, including VLAN IDs, names, IP subnets, and connected devices. You can use network management tools to automatically document VLAN configurations. Secure your native VLAN. Change the default native VLAN, which is VLAN 1 on trunk ports, to an unused VLAN ID. Do not use this VLAN for user traffic to prevent VLAN hopping attacks. Consider implementing VLAN pruning to limit unnecessary VLAN traffic on trunks. Finally, plan for scalability. Design your VLAN structure with future growth in mind. Allocate VLAN IDs in blocks by function or location to allow for expansion without major redesigns. Reserve VLAN IDs for future use in special purposes like management and voice. If you like this video, hit that like button and don't forget to subscribe. Visit codelucky.com for more such useful content.